For grade preparation in transportation engineering, we will see geometric design, highway geometric design. In that, as a topic 1, we will see side distance. In that, we have stopping side distance. Vehicle is traveling in this direction. Suppose a vehicle is traveling in this direction, and there comes a situation where the vehicle is need to be stopped. So from here to here, stopping side distance can be written as lag distance plus braking distance. What is lag distance? It is the distance while you are thinking before applying the brakes. You are applying the brakes here, and this time is called reaction time, which depends on so many factors like age of the driver, gender, health condition, and etc. etc. And reaction time, if the data is not given, it can be taken as 2.5 seconds. So lag distance, if the speed of the vehicle is taken as small v in meter per second. Remember, whenever I write small v during this highway geometric design, it is in meter per second. If I write capital V, it is in kilometer per hour, speed of the vehicle. Then this lag distance can be written as, so small v into t, where t is reaction time. And this t depends on so many factors. So first you have to perceive, and you have to think using your intellection, and you have to emotion, and then volition. This concept, the theory, is called PIEV theory, perception, intellection, emotion and volition. And this entire process, during this entire process which happens in your brain, so that reaction time is T. Now braking distance, which depends on the friction between the road surface and vehicle tires. So that is V square by 2gf, where f is the coefficient of longitudinal friction, means in this direction. Longitudinal friction, if data is not given, this can be taken as 0.35, between 0.35 and 0.4. And this is only when the road surface is straight, between, means there is no grade. It can be ascending grade or road can be in the descending grade. If the grade is given, then that becomes V square by 2gf plus or minus 0.01 n, where n is the grade of the road in percentage. If the grade is given as, so 1 in 50, suppose, then in percentage it is 2%, that is 100 by 50 becomes 2%. And if the braking efficiency is given, vehicle's braking efficiency is also given, then this formula becomes V square by 2g mu f plus or minus 0.1 n. So this positive is for ascending gradient and minus is for descending gradient, and this mu is braking efficiency. Generally 100% is not practical. If they give braking efficiency, then this braking distance becomes like this. So stopping side distance can be written as, so lag distance plus braking distance. If the design speed or speed of the vehicle is not given, then we have to adopt the design speed of the vehicle, and now I'll explain now how to adopt that design speed. Also, this is valid only for roads there is no opposite traffic. So suppose this is a road, only one vehicle is going, there is no opposite vehicle, one-way traffic, or a two-lane road, say if there is opposite vehicle, means single lane road and there is vehicle from the opposite direction also, then this distance should be 2 times stopping side distance. One stopping side distance for this vehicle and other for this vehicle, and this is called intermediate side distance, which is 2 times stopping side distance. Whenever opposite traffic is also there. So remember this. So during calculating side distance, if the data is not given regarding design speed of the vehicle or speed of the vehicle, then you have to adopt a design speed depending on the classification of road and classification of the terrain on which the road is located. Now we have 4 types of terrains. See, we have 4 types of terrains: plain, rolling, mountainous, and steep. So if the cross slope of the country means the area where the road is located, 0 to 10%, then it is plain terrain. It is 10 to 25% rolling terrain, 25 to 40% is mountainous terrain, and more than 40% is steep terrain. Got it? Now we have 4 types of classification of roads: national highways and state highways under one category, major district road, other district roads, and village roads. Now we have 2 types of design speeds. One is ruling design speed and minimum design speed. Ruling design speed means wherever the situation is possible, you have to provide this speed. If it is not possible, then at least minimum design speed should be provided for the vehicles. Now we have under plain terrain, we have ruling and minimum design speed. Similarly, in rolling, for mountainous and for steep, we have design speeds like this. I will tell you how to remember these things. So, these design speeds are in capital V, that is in kilometer per hour. So, 100 is the ruling design speed for national highways and state highways. Similarly, fill like this: 80, 65, 50, 50 and 40 for village roads. Similarly, this 80 you continue it here: 80, 65, 50, 40 and 30. And now for mountainous and steep, we have 25 and 20 are the minimum design speed. Here 50, 40, 30, 25 and 20. Similarly here 40, 30, 25 and 20. So in the question they will give like this, the data. You have to provide minimum design speed for a national highway. They will give like that. So designs are under they'll give some terrain in plain terrain. So in plain terrain, minimum design speed for national highways is 80. So you have to adopt design speed from this tabular column. Now the topic is overtaking sight distance. Overtaking sight distance. So suppose you are traveling in some vehicle A. Suppose this is vehicle A, and there is a vehicle traveling, say suppose some B. If this vehicle wants to overtake this vehicle, we will assume a theory something like this. So whatever the design speed of the road, if this vehicle is traveling at a lesser speed than the design speed, then only the vehicle wants to overtake this one. So if the data is not given regarding this vehicle B, which is to be overtaken, now we will adopt like this. This vehicle is traveling at a speed less than the design speed by 16 km per hour. And this vehicle is traveling at design speed. Now, this vehicle travels for some time at what speed? Whatever speed this vehicle is traveling, this vehicle travels for some time like this. So, it comes like this. And goes like that. Suppose from this point to this point, this travels at the speed of this vehicle for some distance, and then the maneuvering takes place and it accelerates and again moves there. Now if you see this time, this distance can be written as small v into time t. For some time this travels and then maneuvering takes place and goes like that. From here to here, distance, suppose say d2. So initial speed of this vehicle, if you remember the formula from your past, maybe 10th or inter, you will be knowing like this, some s is equal to u2 plus half at square. So distance traveled is initial speed into time plus half of acceleration into square of time. Now in this situation, d2 is equal to vb into t. Suppose the time is t during this time, plus half a t square. If this capital T is the time taken for this vehicle to overtake and again join in that lane. You see, this t2 can also be written as, if this portion and this portion if you take as some this can be written as b plus 2s. Upon comparing these two equations, we get 2s is equal to half at square and t is equal to square root of 4s by a. And where s can be written as 0.7 Vb plus 6 meters, where Vb is the velocity of this vehicle in meter per second and 6 can be interpreted as length of the vehicle. Length of the vehicle as 6, and this 0.7 is this one, this distance. 0.7 times Vb. Now this all happens whenever there is no opposite vehicle. If at all there is a vehicle coming in the opposite direction in this lane, in this particular lane, suppose that is vehicle C, suppose C. Now if I said that is as D3, which can be written as Vc into T, vehicle of the speed of the vehicle coming from the opposite direction, that is Vc into capital T. That T is the time, whatever happens from here to here, that is the capital T. Now overtaking side distance total can be written as small v to small t plus whatever comes here, plus half at square plus Vc into T. If vehicle from the opposite direction is not there, this term is not here. If it is there, this term is here, and the data if not given regarding the speed of this vehicle, then you can take it as design speed, that is small v. This is in meters. Now overtaking zone. What is overtaking zone? If you observe whenever traveling in the highways, overtaking zone starts. You can see the signboard like that. Overtaking zone starts, and after a few minutes or a few furlongs, you can see overtaking zone ends. That overtaking zone, generally where the vehicles are permitted to overtake the vehicles, that zone is 5 times overtaking side distance, and minimum overtaking distance is overtaking zone distance, minimum distance is at least 3 times overtaking side distance. So remember these terms. That's it about overtaking side distance, and the next class we'll see setback distance.